Welcome back to class 8 series on my channel Mathify with Minakshi. In the previous video, we explored squares and their properties. Now, let's move one step ahead, and in today's video, we are going to understand square roots, their properties, and the first figure it out of this chapter. So, let's begin with a simple question. What is square root? Square root of a number x is that number which when multiplied by itself gives x. In simple words, it is the inverse operation of squaring. I will explain you with the help of an example. As you know that 3 into 3 is 9, or you can say 3 square is 9. Then the square root of 9 is 3. And this is the symbol of square root, also known as radical. You can also write like this, or you can write like this. You can write 2 here. By default, if you will not write any number here, that means 2. So no need to write that. You can simply use this radical sign for square root. Or I can say if y square is x, like here y in my example that was 3, then you can say that your root 9 is plus minus 3. Now why I wrote plus minus 3? As you know that 3 square is also 9 and minus 3 square is also 9. So we can say that square root of 9 is minus 3 or positive 3. But as you can see, the first property of square root, that square root of a positive integer has positive and negative root. Though usually the primary positive root is used. So usually we take only the positive root, which is also called the principal root. So if in exam someone will ask that what is root 16, don't get confused if in options we have only 4, not minus 4. If we have an option plus minus 4, then you can go for plus minus 4. But if we have only 4, then you can simply take positive 4, because the principal root we always take as positive root. Now let's move to second property. Square root of an even number is even and square root of an odd number is odd. Let's see some quick examples on the right side. See, square root of 1 is 1. That means square root of odd is odd. Square root of even is even. Square root of odd is odd. Even is even. Odd is odd. Even is even. Odd is odd. And so on. So from here, we can deduce the property that square root of an even number is even and square root of an odd number is odd. Now let's move to the important property. That's third property. Number of digits in square root of a number having n digits. So if someone will ask how many digits, you can say that in square root of 4624. They're not asking answer. They're saying how many digits will be there in the square root of this number. So answer is number of bars. So what you have to do, you have to simply count the number of digit pairs. You can say bars in that number. So usually we always start from right and we move towards left, and we have to give bar to each pair. So first bar is in 24 and second bar is on 46. That means number of digits in the answer of square root of 4624 will be 2. Let's do one more example where we have odd number of digits. Again, you will make bars for each pair and you will always start from right. So this is my first bar on 89, second bar on 12, and third bar will give to the remaining digit, that's on 7. So here the answer will be of 3 digits. Now let's move to next property. That's unit digit of a number and unit digit of its square root. That means suppose you have a square root sign I've written here and the last digit is 1. Then what you can say about the possibilities of the unit digit of the square root of this perfect square. So you should know that if a number ends with 1, as you can see here, if the number ends with 1, then its square root will end with either 9 or 1, as I've written here 1 and 9. If a number ends with 4, then its square root will end with either 2 or 8. If a number ends with 9, then its square root will end with either 3 or 7. If a number ends with 6, then its square root will end with 4 or 6. And in case of 5 and 0, we have only one possibility. If a number ends with 5, then your square root will also end with 5. And if a number ends with double zeros, then square root will end with single zero. Basically, you know that number of zeros becomes half when you will find the square root of a number. So I have attached table here too, that if a number ends with 0, then square root will end with 0. If a number ends with 5, its square root will end with 5. And for the remaining digits, we have two possibilities. It might be possible you are thinking why I didn't wrote these digits 2, 3, 7, 8. As I told you that under square root, we have a perfect square. And perfect square never ends with 2, 3, 7, 8. That's why this unit digit can't be 2, 3, 7, 8. So that's why I didn't wrote those digits here. Now, did you observe something here where we have two possibilities? Just see here carefully. Yes, sum is always 10. So if you know one digit, you can just simply subtract that digit from 10 to get the other digit. Now, let's move to methods to find square root of a number. So for that, we have four methods: repeated subtraction method, prime factorization method, long division method, and estimation method. So let's start with one example. Let's say 121. So you have to find square root of 121 with the help of these four methods. First, start from repeated subtraction. In repeated subtraction, you have to simply subtract consecutive odd numbers from the answers what you will get. Like 121 minus 1, that's 120. Now you will subtract 3 from this 120. That's your second step. 120 minus 3, that's 117. Now you will subtract the next odd number from 117. That's 5. So 112. Then you will subtract next odd number, that's 7, from 112. Then you will subtract 9 from 105. And similarly, you have to do this until you will obtain 0. So we'll continue this. 96 minus 11, that's 85. Then 85 minus 30, 72. Then 72 minus 15, that's 57. Then 57 minus 17, that's 40. Then 40 minus 19, that's 21. And then 21 minus 21, and that's 0. So you will write, as we obtained 0 at 11th step, this implies that square root of 121 is 11. So basically you have to find this until and unless you will get the answer as 0. And whenever you will get 0, you have to see the number of step here. If it's 11, so answer is 11. So this method is not good if the number is big, because someone will say that you have to find the square root of any number whose square root is, let's say, 49. So you have to write 49 steps for that. That means this method is not good when the number is too big. So let's move to prime factorization method. So again, what you will do, you will take prime factorization of 121. You know this, it's 11 into 11 and then 11 into 1. So square root of 121 is, first you know that 121 is 11 into 11. So when you will put a square root here, so you have to write one number for each pair. So answer is directly 11. Now let's move to long division. So in long division, first thing that you will do is you have to make bars. So again, we'll move from right to left. So first bar is in 21 and second bar is on 1. Now you have to read the table of squares and just stop when, like I will write here for you, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, and so on. Like this, you should know. Now you have to see the squares, this number 1 or less than 1, but we have exactly 1, so just see the number left to this. That means square root. So 1 into 1 is 1. Now remainder is 0. Normally in division we used to carry one digit at a time, but here we have to carry the whole bar. So you will carry 21. In next step, you will simply take the double of quotient, or you can say you will add 1 plus 1. I'm taking writing double of quotient, that is 2. Now here you have to write one digit in this square in such a way that it should be same. So you will hide this one. No need to see this one. Just hide this one. Now one time you will put 0 and 0, like 20 into 0. I will write here for you, like 20 into 0. Then 21 into 1. Then 22 into 2. So this number you have to read full. And for here you have to just read this digit. But these two digits should be same, that you have to write in box. So 20 into 0, 21 into 1, 22 into 2. And you have to see when you will get the answer. 20 into 0 is 0. 21 into 1 is 21. 22 into 2 is 44. But we get the answer at 1. So you will write 21 into 1. That's 21. So final answer, you have to see just the quotient. What is your quotient? It's 11. So that's your answer. I will explain you this method while doing quotients. So at that time it will be clear to you. Now let's move to last method, estimation method. Estimation method is good when someone will tell you that you have to find the square root of a perfect square. Then you can find the answer directly. But if they will say that you have to find the square root of any non-perfect square, then estimation will give you the answer for this too, although it doesn't exist, but estimation method will give you the answer, and that's why this method is known as estimation method. Like now maybe you are thinking that what about these three methods? We'll get to know that the number is not a perfect square, or it's a perfect square. Yes, in repeated subtraction you will follow the steps, but you will not get zero. Your answer will go in negative. That means yes, the given number is not a perfect square. In prime factorization, if any prime number doesn't occur in pair, like here we have pair, but there is one number left that doesn't have a pair, then you will say that's not a perfect square. In long division, if you will not get remainder as 0, then you will say it's not a perfect square. But in estimation method, we can't say by seeing the number that it is a perfect square or not. It will give you answer, either it's a perfect square, it's not a perfect square, and if it's not a perfect square, it will give you wrong answer. That's why name of this method is estimation method. Now we have to find the square root of 121, and this is a perfect square, so this time it will give you correct answer. What you have to do, first step is same, you have to make bars like in long division. Second step, as you know that we have one property, number of digits in the square root of any number is equal to number of bars. So here we have two bars, that means in our answer we have two digits. Now what will do for ones digit and what will do for tens digit? So we have to follow two things here. For tens digit, you have to simply read the table of squares I've written here. So just see the number 1. You will see the answers either this number or less than this number. But 1 is here. So you will see the number in front of that. So you will write 1 directly. If the number is, let's say here it's 3, then again you will see 3 is not here. So you have to select 1. If a number is, let's say 7 here, then you will select 4. That means you will write 2, like this you will do. And what about this? For this you will see that ones digit, fourth property of that square and square root, who are the friends of 1. If you know, I will show you that once again. Yes, see here, when a number ends with 1, then its square root can end with 1 or 9. So if you know this thing, you can simply say here that here for one digit we have two possibilities, 1 or 9. How you can learn this? I will tell you one way to learn this. Suppose a number ends with 1, ends with 4, ends with 9. Just simply imagine what's the square root of 1? It's 1, other number is 10 minus that. If a number ends with 4, just imagine what's the square root of 4? It's 2, other number is 10 minus 2. If a number ends with 9, just imagine square root of 9 is 3 and other number is 7. But for 6, as 6 is not a perfect square, so just write the same number, another is 10 minus that number. For 0, it's always 0, and if a number ends with 5, it's always 5. So you can learn that table with the help of this method that I just told you. So if a number ends with 1, just imagine square root of 1 is 1, another is 10 minus 1, that's 9. Now how I will select between 1 and 9? You have to simply multiply your tens digit. What is your tens digit? It's 1. You have to simply multiply this with its next digit. That means 1 into 2, it's 2. Now just see your quotient, it's 1. If this is less as compared to this, here 1 is less than 2, then you will select the smaller number. So it's 1. And if this, suppose it was 3. If it's more than this 2, so you will select 9. So answer is 11 here. Now let's start figure it out. That's on page number 10, question number 1. Which of the following numbers are not perfect squares? So you know that we have two properties that tell that number is never a perfect square. First, if the unit digit is 2378, and second, if number ends with odd number of zeros. But we don't have any property that says that by seeing the number that it's a perfect square. If we have to say see that the number is a perfect square or not, then you have to follow any method like prime factorization, long division, or repeated subtraction to check that the given number is perfect square or not. But we can say that when a number is never a perfect square by seeing these two properties. First number ends with 2, that means it's never a perfect square. Second number ends with 8, again it's never a perfect square. And third number ends with 7. So for first, second, and third, we can say they are never a perfect square, as a perfect square never ends with 2, 3, 7, 8. Now what about fourth part? That's 1089. Again, here the unit digit is 9. So for that we have to check by taking prime factorization, long division, or repeated subtraction. So I am doing prime factorization. As you know that sum of digits is 18, so it's divisible by 3. 3 into 3 is 9, then 1 left, 18, that's 6, and then 3 into 3, 9. Again, you can divide it by 3, you will get 1 to 1, and 121 is the square of 11. So you can say that 1089 is a perfect square as each prime factor occur in pair, and you know that it's a square of 3 into 11, that's 33 square. So answer of first question is first, second, and third part. Fourth is not true because they are saying which one are not perfect square. Let's move to question number 2. Which one among 64 square, 108 square, 292 square, and 36 square has last digit 4? Now you have to just check their unit digit. So unit digit of 64 square, you have to just take the square of unit digit. 4 square is 16, that means it ends with 6. Unit digit of 108 square, just take the square of unit digit, that's 8 square, 64, so it will end with 4. Here 292, so unit digit is 2, 2 square is 4, end with 4. And last is 6 square, that's 36, it will end with 6. So they are saying which one end with 4? So answer is 108 square and 292 square. They will end with 4. Now let's move to question number 3. It's given that 125 square is equal to 15625. Then what is the value of 126 square? And 5 options are given to you. As you know that we have discussed in a previous video that in case we have to find the square of a number and we know the square of its previous number, then you have to simply add nth odd number with n minus 1 square to get n square. Now just see here. Here n square is 126 square and 126 minus 1, that is 125 square. So we know 126 square is equal to 125 square plus 126th odd number. Now what is 125 square? That's given 15625. Now 126th odd number, that is 2 into 126 minus 1. Double minus 1 is odd number. That means 15625. Now double of 126, that's 252 minus 1, that's 251. No need to solve because if you will see that we have one of the option here, that's fourth option is correct. Now let's move to next question. Fourth question, find the length of the side of a square whose area is, that means it's given area is 441 meter square. We know the formula of area of square, that side into side. You can say side square is given 441 meter square and we have to find side. Now we know side square and we have to find side. So how we'll do that? That means you're taking square root both the sides. If you will take square root both the sides, then what you will get? If you will take square root this side, then you know that square and square root are inverse operation. You can cut that, and here square root of 441, again meter square becomes meter. That means your side is square root of 441, and we can find the square root using any method, but this time I will tell you long division, so that you know that how we can do long division. First you will make pairs and you will always start from right and move towards left. Now I told you that you have to read the table of square. I will write that for you so that it will be easy to explain. See, we have 4, so you have to select right side, either 4 or less than 4. So we have 4 here, just see the number left to it, that's 2. 2 into 2 is 4. Now 0 left and just carry 41 together. Now we have to take the double of this. Double of 2 is 4. Write this and then we'll write one digit here and no need to see 2 now. So I will put a cross here. So what you will do? You will do like 40 into 0 one time, then 41 into 1, then 42 into 2, and you will see that when we'll get answer as 41. You know that we'll get answer at 1. 41 into 1 is 41. Although I will tell you trick here. If a number ends with 1 and you know it's a perfect square, then possibilities for this digit that I've written in square are 1 and 9. You know the property of unit digit. If a number ends with 1, then its square root will end with 1 and 9. So when the number is a perfect square, you can simply use this trick too. So you can just try for 1, 41 into 1 and 49 into 9. So that means your side is 21 meter. Answer is always quotient. That's 21 meter. Now let's move to question number 5. Find the smallest square number that is divisible by each of the following 4, 9, 10. Now you know that you read in 5th and 6th class that smallest number that is divisible by the given number is always divisible by 4, 9, 10 is always their LCM. That's LCM of 4, 9, 10. But I missed one word here. If you will see carefully, square. So first I will find the smallest number that is divisible by all, and then I will check that my LCM is a perfect square or not. So first do that. Let's find the LCM of 4, 9, 10. So we know how we can find the LCM. First we'll divide by 2. 2 into 2 is 4. 9 as it is, and then 2 into 5 is 10. Again we'll divide by 2. 2 into 1 is 2. 9 and 5 you will write as it is because you can't divide by 2. Now we'll divide by 3. That is 3 into 3 is 9, then 5. Again we'll divide by 3. 1, 1, 5. And at last you will divide by 5. Now just see the LCM. What is your LCM? Right. 2 into 2 into 3 into 3 into 5. Now is this a perfect square? Although it's a 180, if you want to say it's 180. Is it a perfect square? You will realize no. Why is it so? Because 2 half pair, 3 half pair, but 5 is alone. That means this 180 is not a perfect square. So they are saying that you have to tell the smallest square number. Now you know that the number that is divisible by 4, 9 and 10 is always either LCM or its multiple. So you can multiply any number with 180 because you know that if you multiply any number with 180, it still divide all the numbers 4, 9 and 10. But we need square too. But for square, we have to multiply by 5 because you know in square, all the numbers should occur in pair. So that's why in order to make it a square, we'll multiply by 5. That means you can say 180 into 5, that is 900 is the smallest square number that is divisible by 4, 9 and 10. Now let's move to question number 6. Find the smallest number by which 9408 must be multiplied so that the product is a perfect square. Find the square root of the product. See, whenever it's written that by what number you will multiply, divide, add or subtract, that means the given number is not a perfect square. That you should know. So for multiply and divide, we always follow prime factorization method. And for plus and minus, if they will say what you will add or subtract, you always follow long division method. You have no other option for that. So learn this. Whenever they say that you have what you will multiply or divide to make a number perfect square, always follow prime factorization. And whenever they will say what you will add or subtract to make a number perfect square, always follow long division. So here the word is multiplied, as you can see here. The word is multiplied, so I will do prime factorization. So I will take prime factorization of 9408. As the last digit 8 is even, so we'll divide by 2. 4704. Again the last digit is even, so I will divide by 2. 2, 3, 5, 2. Again the last is even, so I will divide by 2. 1, 1, 7, 6. Again the last digit even, I will divide by 2. 5, 8, 8. Again the last is even, I will divide by 2. 2, 9, 4. Again the last is even, I will divide by 2. 1, 4, 7. Now the last is not even, so I can't divide by 2. So just see, can we divide it by 3? For that, you have to take the sum of digits. 1 plus 4 is 5, 5 plus 7 is 12. Yes, sum is divisible by 3, so number is also divisible by 3. 3 into 4 is 12, and 2 left, 27 is 9. Now 7 square is 49. Just see that 2 have a pair, 2 have a pair, 2 have a pair, 7 have a pair, but 3 doesn't have a pair. So they are saying by which number you will multiply to make it a perfect square, you will multiply by 3. But you have to multiply by 3 both the sides. As you know that your number 9408 can be written as 2 into 2 into 2 into 2 into 2 into 2 into 3 into 7 into 7. So you will multiply by 3 both the sides. 9408 into 3, and in prime factorization 2 you will multiply by 3. Now what is 9408 into 3? That's 28224. So just copy this as it is. You know that 28224, this is the number, this is a perfect square. But they are saying that you have to find the square root of this product. So you have to find the square root of this number too. So how will find the square root? Whenever you will put the symbol here square root, then each pair you will write only one time. So you will write 2 3 times because we have 3 pairs of 2, and 1 time 3 and 1 time 7. Now this is 2 into 2 4, 4 into 2 is 8, 8 into 3 is 24, and 24 into 7 is 168. So that is your final answer. Now let's move to next question, question number 7. How many numbers lie between the squares of 16 and 17? That means they are saying between 16 square and 17 square, how many numbers are there? You have to find. And similarly, between 99 square and 100 square, how many numbers we have? Integers they are saying. So you know one property that between n square and n plus 1 square, we have 2n non-perfect squares. So using this property, you can say in our case, our n is 16 in first, and second is n plus 1, that's 17. So we have to simply multiply 2 with smaller numbers. So here the answer is 2 into 16, that's 32. And here the answer is 2 into 99, that's 198. So you have to always multiply 2 with smaller number, and just mention this property. Now let's move to eighth question. In the following pattern, fill in the missing numbers. So you have to observe this pattern and then fill three blanks. Just see the pattern carefully. Just see the base here. 1, 2, then 2, 2, 3, then 6, 3, 4, then 12. Did you observe something? Yes. This third number is the product of first two. So here 9 into 10 is 90. Yes. Now what about this blank? Here it's the next number 2, then 3, 6, then 7, 12, then 13. We are just talking about base 20 and then 21, 90 and then 91. It's the next number. Now let's move to last question. How many tiny squares? They are saying tiny squares are there. So let me tell you what is tiny square they're talking about. This one is tiny square. So are there in the following picture, and write the prime factorization of the number of tiny square. So first you will see that how many rows we have. Rows are 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many columns we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means you can say that number of big squares are 9 into 9. Number of big squares are 9 into 9. You can say 9 square, that is 81. So we know that we have 81 squares here. And in each square we have how many tiny squares? Just see 1, 2, 3, 4, 5. 5 into 5. Here 5, here 5. So total are 25 tiny squares in one square. So number of tiny squares in one big square is 5 square, that's 25. So they are saying total number of tiny squares total number of tiny squares? So for that, you will simply multiply this 25 and 81. And what you will get when you will multiply them? You will get 2025. Now they're saying that you have to prime factorization of this number. So 2025. So you can divide it by either 3 or by 5. If you feel that you have to divide by 5 as the last digit is 5, you can do that. It's in prime factorization, order doesn't matter. So suppose I will divide by 5 first. So it's 405. Again, the unit digit is 5, so you can divide by 5 again. 5 into 8 is 40, then 1. Now you will divide by 3. That 3 into 27, then 3 into 9, then 3 into 3, then 3 into 1. So, what is the prime factorization of 2025? You will write prime factorization of 2025 is 5 into 5 and 3 4 times. So that's it. We are done with our first figure it out of this chapter. Now we'll continue this chapter in next video. If you found this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Thank you everyone.